Hey everyone, welcome back to Pepcoding. In this video, we are going to solve a new question, which is next greater element to the left. So what is given in this question is, we are given a number n representing the size of array A. We are given n numbers representing elements of array A. We are required to find next greater element on the left for all elements of array. And what is next greater element? So next greater element on the left of an element x is defined as the first element to left of x having value greater than x. So we have to note one thing: if an element does not have any element on its left side greater than it, consider -1 as its next greater element on left. Right. And this example is given. Let's analyze this example first. So we are given an array, this one, and in the answer array, what we have to give, we have to see the element next to it, at the left, next greater element to the left. Okay, so if we check for 1, the first greater element, the next greater element to the left, which is 3. 9 is also greater, but it is not the first element which is greater. First element which is greater to 1, to left of 1 is 3. So 3 will be the answer here. If we check for 2, there is no left to it, so -1 as per the question. Then for 5, the next greater to is 2 is smaller, so there is no element greater to it on the left, so -1 will be the answer here. 9 will check with 5, it will go here. 5 is smaller, then it will go more to the previous here, and 2 is also smaller, so -1 will come here. Now 3 will check with the 9, it is greater, 9 will be the answer here. So check for 1. Let's see for 12. It will check for 1. 1 is not greater. 3 is not greater. 9 is also not greater. 5 is also not greater. 2 is also not greater. So -1 will be the answer. So like this, we have to update our answer here. So what we have to actually do is, first, let's see the brute force approach here. What is happening in the brute force approach? We'll iterate the whole array, right? So we'll make an ngl. Name of the array is ngl, in which we'll store our answer. So it will check for 2 first. There is no element to the left of it, so -1 will come here, as we have discussed before. 5, 2 is smaller, there is no element next to it, so -1. 9 will check with 5, then it will check with 2, both are smaller, so -1 will be the answer. Now 3 will check with the 9, 9 is greater, so 9 will be the answer. 1 will check with 3, 3 is greater, 3 will be the answer. 12 will check with 1, it is smaller, then check with 3, it is also smaller, then it will check with 9, this one is also smaller, then 5, then 2. So -1 will be the answer. 6 will check with 12, 12 will be the answer, 12 is greater. 8 will check with 6, so it is smaller. Now it will check with 12, so 12 will be the answer here. 7 will check with 8, 8 will be the answer here. So this is how it is coming. But this one, how much work is done? For 2, it is not checking anyone because it is the first most left of the array, so 0 work is done here. For 5, 1 work is done here, it is checking with only one value, which is 2. For 9, it is checking with 2 elements, so 2 work is done here, right? So that's how it is going on. In the worst case scenario, like if it is given A, B, C, D. Like this is the array given. And so what will D will check for? D will check with three values for B, C and A. Right? So work done for D is 3. So for the worst case scenario, if this array was given in the ascending order, then our work done will be 0 plus 1 plus 2 plus dash 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 plus till n minus 1 till all the elements, and it will be equal to O of, like it will be n into n minus 1 by 2, right? The complexity that will come is O of n square. So it is not the best time complexity, so it was the brute force approach. Now how we can optimize this we can't do, because it is not an optimized approach and it will take much more time. Okay. So as this was the array given to us, what we'll do, we'll take a data structure which will grow dynamically and can store multiple values which we want. So what we'll do, we'll take this 2, this will be our answer. What will be our algorithm, right? So first we'll store 2 here, answer will come, right? 5 will check with 2. If it is greater, then it will come here. If it is smaller, the peak of here is smaller, then what will it do? It will pop it out and minus 1 will come here, right? And will push itself also. Now for 9, it will check with 5. If it is smaller, like what is happening here, we have marked 2 as smaller. Now 9 will check with 5. If it is smaller, then it will be marked and 9 will come here. Now 3 will check with 9. 9 is not marked, 9 can be the answer, right? Then but 3 is not marked here, right? Okay. So 1 will check with 3. 3 will be the answer. 12 will check with 1. It will be marked because it is smaller than 12. Then it will check with 3. It will also be marked. Then it will check with 9. This one will also get marked. And it will not check further because they are already marked. So it will be popped out and it will get an answer as minus 1, right? Now for 6, it will be checked with 12. So 12 will be the answer here. 8 will check for 6. 6 will be marked because 6 is smaller than 8, right? Then 7 will check with 8. So it will also get an answer. So what we are doing here, let's analyze this approach. So what we are given, 2, 5, 9, 3, 1, 12, 6, 8 and 7, right? Let's erase this one also. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So we are making a stacked data structure in which the elements will be stored from here, like add last, and will be removed from here only, right? Okay, so we'll start with the algorithm. Like first 2 It will be -1 because there is no left element. It will be pushed to stack, right? Next, what we'll do, 5 will check with 2. If it is smaller, then it will be popped out and 5 will added here, -1 will come here. So which algorithm is going on here is while peak of the stack is smaller than area of I, then pop the element in the stack. Okay, and we have to, this is the answer, right? Push the area of I. Okay. So for 9, what we have, it will check with the peak. This one is area of I, right? 9 is area of I. We'll check with the peak, which is 5. 9 is greater, so pop 5. Pop 5 out. And 9 will be pushed, right? So -1 will be the answer. Next, 3. 3 will check with the peak value of the stack. 9 is greater, so 9 will be here. Let's check. Let's make it different. Make it 3. Check it for another test case. If it is 3 here and 3 will be pushed here because of this one, then 3 will check with 3. 3 is not less than the value of peak, so it will be popped out and this 3 will be pushed in the stack. And here comes 9 only. Then 12. 12 will check with 3. 3 is smaller, so it will be popped out. Now it will check again with the peak of the stack, which is 9. So it is 9 is also smaller than 12. So 9 will be popped out. And we have 12 here. 12 will be pushed. So -1 will come here. Then for 6, it will check with the peak value, which is 12. So 12 will be the answer. 8 will check with the peak value, which is 12. 12 will be the answer. 7 and 8 will be pushed. No. First 6 was pushed, but 8 will check with the 6, but it is smaller. So now 8 will be pushed. Now 7 will check with 8. If it is greater, then 8 will come in the answer. So what we are doing here is, if this those elements which are smaller than the particular element, then the next element will not check those elements which are smaller than the previous element, right? So like for 12, 12 will check for 9, but it will not check for those elements which were smaller than 9, right? So I think this algorithm worked for us, and let's code it. Okay, so we have this question. We are given a function solve and we have given return type as integer of array. So what we'll do, we'll make int n equals to array dot length, and what we have to do, make an answer array ngl equal to new int, size will be n. Next we'll make a stack of integer type, okay, st equals to new stack. Next, for we'll iterate in the array for int I equals to 0, I less than n, plus plus, right? Then we'll check the condition while our st dot size is greater than 0 and st dot peak is less than equal to area of I, right? We'll st dot pop that element out. Okay, next we'll check the condition. If st dot size is still remaining is greater than 0, then what we'll do, ngl of I equals to st dot peak, right? Next, what we have, will come in the else part. Else ngl of I will contain the value as -1 as per the question. Next, what we'll do, st dot push array of I, right? And what we have to return, we have to return that answer array which was ngl. Let's run this code and see if it's correct or not. Accept it. Let's submit this code. Correct answer. So I hope I was clear with the concept of this question, and thank you so much for watching this video. I'll see you in the next video. Don't forget to like, share and subscribe to our YouTube channel. Thank you so much.